I would like to welcome Matt Pendleton with NOAA. He is with the Office of Coastal Management in the Southeast region and Caribbean, and he's the geospatial coordinator, and he's going to present to us about high-resolution land cover for North Carolina. So let's please welcome him this morning.
Good morning, everyone. As she mentioned, and Jim gave a brief kind of segue into what I'll be talking about today, we're talking about the new coastal land cover, the Coastal Change Analysis Program, or the CCAP program. So if you've worked with land cover, you know it's both a blessing and a curse. So what we're trying to do is really enhance this program through some recent funding that we had. If you're not familiar with the Coastal Change Analysis Program, it's basically an authoritative source for land cover in the coastal U.S. It ties into the NLCD, which is National Land Cover Database, but it's primarily a coastal product. It is an official FGDC National Geospatial Data Set, and typically what it's been is regional products at 30 meters. Historically, we've updated them every year from 1996 to 2021. You may be familiar with our Land Cover Atlas, which basically you look at change over time for those products. That's kind of the power of those products and many other types of mapping and analysis that are done on them. Most of the history, we focus on mapping from Landsat imagery and monitoring changes. So we update those products every 5 years. 2021 update to those regional monitoring products is available now, so I'll be talking about those as well. And we've been producing this data for decades, and we've actually been using AI for that for most of the time, you know, remote sensing, machine learning-based environment. So the problems with the CCAP data in the past, you know, the resolution of that data has not been supported for all the needs and uses that people want to use it for. You think it's a 30-meter resolution, so almost the size of this room would be one cell. And within that cell, you could have many different types of classifications. So not really useful for finite studies, but more of a regional analysis. These high-resolution products at 1 meter have been historically expensive to produce. Faster, cheaper, better is now possible. There's an old saying of pick two, pick two of those. So the 2020-2021 national build-out is in progress. And then this is a new baseline for us because you can't really take a 30-meter product, go down to a 1-meter product, and look at change over time. There's just too much. Like in the previous presentation, it's a 900. The 1-meter resolution is 900 times better than the 30-meter product, so that's hard to compare. We are kind of backscaling that traditional 30-meter product to make it compatible to look at change over time, so that's coming as well. And then continue with this new baseline product and update that every 4 to 6 years. So comparison of resolution, if we look here, this subset is that piece you see over there, but before with this data and all these classifications, you could really only do a regional analysis, and that was about as good as it gets. With that local 1 meter, you can really get into that fine scale and do an analysis on a watershed or a sub-watershed or, HUC codes or something. So these are the classifications for all of the CCAP data. You can see there's the developed, the uplands, the wetlands, the water, bare land, and the aquatic beds as well. So the high resolution can support all the many applications that standard 30-meter products can, with the added advantage of giving more regional applications greater precision and accuracy. If we zoom in a little more, these are the same comparisons. That regional 30-meter, it's really hard to tease out. Looking at individual wetlands, you can see the unconsolidated shore is not really captured in this at all, so you can see the improvement that resolution is going to get us. So much more detail can support mapping applications and decision making at the local site level versus a regional level. This slide, I like to say, this is what I see before I put my contacts in the morning. And then when I put them in, that's what I see. So it's a good comparison to that. This is looking at impervious surface. So much more detailed impervious surface. You know, we're getting down to the sidewalk level with this mapping. So urban area mapping can be used to support better hydrodynamic modeling, flood risk assessments, stormwater management, and more. And before, it was kind of typically hard to do with that. Your results were not great. Not only in the urban areas, but in the rural areas, this is important as well. The spatial detail is needed in rural areas. I mean, highlights just how limited the 30-meter data is for some of these applications. This example highlights roads, rural neighborhoods, but the same is true of the features like narrow riparian buffers that you would need to do studies in these areas are not really captured in this information. So the detail is really highlighted there. In wetlands, many coastal wetland systems, many changes in salt marsh areas, for instance, are much smaller than what can be reliably seen at a 30-meter resolution. Erosion along the edges, formation of pans and pools, so more detailed natural area, especially when it comes to wetland habitat mapping, which is critical in coastal states where we have a lot of wetlands, and we have sea level rise, we have accretion, we have loss and erosion, so we can really see that. And this is factored into our sea level rise viewer. We have a marsh migration tab where you can change, you raise the water levels, you can set your accretion rates to really look at see how those wetlands are going to migrate in the future as sea levels rise. So what do we have now? These are available for coastal North Carolina right now. We have the 1-meter impervious, canopy, and water mapping. So these are all available on the digital coast right now with the plan to build this out for the entire state. So North Carolina has partnered with NOAA to map the entire state for the CCAP. And so we'll get to that timeline in a little bit. But this is all possible thanks to the bipartisan infrastructure law, Great Lakes Restoration Initiative, and other partner funding, including North Carolina partners. So, you know, we're just concerned with North Carolina, but this is our phase 1 mapping that is available now. So that dark blue, everything is available now. For those 3 classifications, other coastal buy-up options, which North Carolina did, you can see North Carolina is not on that map, but we'll get to another one that shows what is going on. Right now, we're doing the state of Maine. We're doing all the territories, and they're very much smaller geographies, so those won't take very long, and then North Carolina is coming after that. As you know, we've lost some staff, and they're not backfilling that staff, so we've had a few setbacks in our plans for that. So impervious mapping, this is a really important one. This is a big improvement over products we produced even just a few years ago. You can see, because this was machine learning, it tried to tease out that impervious. It looks like snow down to the street level and even sidewalk level with the 1-meter product. The only use restriction for this data is, you know, it's a free publicly available data set, so our vendor has their own proprietary algorithm using AI and machine learning to create these data sets. The only use restriction is that you can't use this data to train another model. So it's just a kind of a broad use restriction. Doesn't mean a lot to some people, but that's just them for a period of 5 years from the date of creation. So when the new data set comes out, that starts the new 5 years on that use restriction. So the expanded CCAP scheme land cover, that builds upon the initial data to map that 20 categories that we see. Really gives an authoritative, consistent, flexible source of land cover and a new baseline for new products going into the future. As good as that data is and as useful as we hope you find it, they're not perfect, no land cover product is, so we're really trying to refine that process over time. In between those 5-year collection periods, we're refining the data, we're going back and working with the vendor to retrain and update some areas. And these products are not our end goal. We really look to kind of continue this advancement in the future. So now we're working to take those initial layers and building out the full CAP scheme. So we've got those 3 now. This is what's coming. This is a pilot area in Tampa where we did a lot of testing, and you can see all those classifications and really how down to the local site level you can get with this information. So this is the phase 2 mapping, expanded land cover, and you see now that North Carolina and both South Carolina are captured in that with those buy-up options. And one good thing about that is those will be working on North Carolina and South Carolina in tandem. So you have that border and you won't have a hard stop line on the southern part of the state. You know, you'll have watersheds that are in both North Carolina and South Carolina. You'll have wetlands, so you'll have that seamless kind of transition into South Carolina as well, which is important for a lot of mapping applications. These are the land cover categories. Those derive most directly from our first phase data products highlighted in bold, so the impervious, the canopy, and the water in bold, and these are the other ones that are coming. We make some corrections of those and expand mapping out and include more detailed land use in wetlands. We work with a lot of folks on kind of expanded wetland habitat mapping. I think 8 national estuarine research reserves. We're working with them doing more detailed wetland mapping, and some other organizations as well. This is an example of the next gen high resistance CCAP. So what you see here will be coming for the entire state, and we'll talk to the timeline in that in a little bit. Another kind of more zoomed in example where you can really see the detail and the precision, even these little pathways. So even the impervious, there's another buy-up option where you can break that out into roads, train tracks, building footprints to really kind of tease apart that impervious surface layer. So some example land cover applications. What are people doing with this? One example is the state of Florida. Improved flood modeling and risk assessment. SLOSH modeling, so that's the storm surge display program that the National Hurricane Center uses. When you see those graphics, when a hurricane's coming and see the surge estimates, that's what SLOSH is. The hydrologic modeling for flooding and stormwater assessments, and also evaluating what structures and roads and other development is at risk from the flooding. Stormwater management, So wetland, I talked about this is in our sea level rise viewer. We use the SLAM model, which is sea level affecting marsh migration, and look at how accretion rates and sea levels will change that. So that's historically been built on that 30-meter product. Now we're starting to integrate that 1-meter product into, as we build out this data set into our sea level rise viewer to get a really detailed marsh migration model. So state of Connecticut has built out this viewer. You can see these screenshots on here. So local watershed assessment tools. It's a really neat site. They're using this data to build that tool and to run the scenarios out on it. We are working on the kind of very similar tool. As we build out the data, we're going to be integrating it into these local watershed assessment tools where you can really see that change and get all kinds of nice statistics and graphs on the change that's occurring with that. The city of Charleston has used this data to assess urban heat areas and street canopy equity, similar to tools like America's Forest Tree Equity Score tool. So this just highlights all the uses that people are doing it. This is a big one. We have all these stories are on our Digital Coast site. There's a stories page that you can read what folks have done with this. This was a new one, discovering gaps in broadband access in Alaska. And I've seen a lot of presentations and information about broadband here as well, and expanding into Western North Carolina. So it's a great story to look at and see what they did, how they used that information to get there. So wetland monitoring, more wetland monitoring, resilience analysis, and comprehensive planning in the state of New Hampshire. Work our office has supported in partnership with the National Estuarine Research Reserve System. So marsh resilience and comprehensive management in New Hampshire, just more examples of how this data is being used. And so the timeline for North Carolina, we do have a partnership with groups in the state, including DEQ. It's a great state working group for land cover, and they want to use CCAP as an official state land cover. Discussions were really kind of limited until the wetland mapping became a topic of discussion. That was really kind of the driver for this statewide collect. We were able to get partners, to get funding, to get work done for the entire state. We are currently trying to push the task order. The agreement is in place and the funds are allocated. Plans are that the task order in a few weeks. So right now we have those 3 classes in the coastal states, or the coastal counties. The first goal is to expand those statewide. So the vendor is working on that now. Should be complete by this summer. And then once we have that, that's what the model, the machine learning is built off of, to use those classifications to do the rest of the other 20 or so classes, which would be coming in hopefully early 2026 to have that entire state build out. Again, we have some constraints. It's a little chaotic right now, but we're moving forward with that plan as best as we can, and we're still hopeful for that outcome. So with that, I will take some questions. I guess I have a few minutes left. Yeah, Jim.
So you mentioned that you want to incorporate this into your sea level view riser. What's the timeline on that?
They're doing it as the data sets come out. So you'll see, because it's all based on elevation data in that model, the sea level rise viewer. And so as the states, but like Maine's about to be complete, that will be updated. There's going to be a little gap. It's not going to be instantaneous because that requires, actual people doing stuff. So hopefully not long after. They're not going to wait for the entire nation to be captured before they start that work, basically, because that would be quite some time. Yes?
How challenging is it to manage like the different groups that are working on these, like creating the training samples to create the habitat maps?
I don't know, because our role is the vendor provides us with a product, then we review it, and we go in and we test areas, and we send that information back to them, and they retrain their models based on that information. Yeah, don't know the entire details of that. Some other folks would, but I don't. I just review.
Are all of the states that are doing the buy-in, are they all following that same use limitation? Basically, are all the data will be publicly available, or are some states keeping them?
All of it is publicly, is taxpayer funded, so it should be how they use that information. It might not be easy to find, but it'll be all publicly available on our Digital Coast platform to get. Yeah.
And then, as I understand it, there's some rules for NOAA is the reason you haven't gone to the non-coastal states. Some contract limitations or something. So
It's probably cost, and we're a coastal office. The plan is to do that for the entire country. Yeah, eventually, that's the vision. Yep. Yes.
You mentioned restrictions on training other models with this data for 5 years. Can you go into that a little bit more? I know in like certain research scenarios, you want to be able to use high quality data to train things for habitat usage and all that. I just wanted to know a little bit more, understand better.
Yeah, I would like to understand more better myself. I don't know, the project lead, the federal lead on that would know more, but it's just kind of in the details. What that really entails is a little unclear to me, because so many people are trying to use data to train their own models. I think it's more of a private industry thing. So like competitors. People doing research and stuff like that, I don't see a problem with that, but if you have 2 vendors that are competing for contracts, then it gets a little muddy. Yep.
You talked about your kind of QA process from the NOAA side. They give you a section that you guys check and send back, and then eventually the final product is exposed to us. If there's something that is missed even after the final data is sent out, something that's like obvious and large, not like little small things. Do you guys have any process in which you might make updates to the data incrementally throughout a year, or is the only update when the next data comes in?
No, so when that time period between the collections, the team is working on refining that data continuously. Because there are, like an example of when I reviewed some of the data, if you had just a kind of bare field and you have a tree here and there, and those aren't captured, and I would send that information back to them, and they said, well, that really doesn't apply to the grand scheme of things, just identifying one tree. It's more about the kind of the whole of the entirety of the data set. But it is constantly refined, during that the team doesn't get a 5-year break between the data updates, so it is constantly worked on. And like I mentioned, we work with some, like the NEARS, to do more defined, wetland studies and things like that, and other kind of one-off partnerships to really refine the data in areas that they're concerned with. Well, thank you.
Yeah.